Motion. Motion is exactly opposite to rest. And rest, is hypothetical. We don't know any object that is perfectly in rest. Whatever we have in our nature, that's always in motion. Even the earth. Earth is in constant motion. And when you are sleeping, then also you are having the velocity 30 km per second, that of the earth. So motion is real and rest is hypothetical. When will you define motion? When the position of the object is changing with time, this would be known as motion. And if this is along a straight line, this would be called rectilinear or straight line motion. Now, for motion, we have studied speed and velocity both. We want to know what's instant velocity. For instant velocity, this formula that we got for average velocity, this will be subjected to the limit, again as in the case of instantaneous speed. This limit delta t tends to 0 and this becomes instantaneous speed. Now, this is no more average. This will be called instantaneous speed, which is normally not mentioned in general discussion. V becomes this much, ds upon dt. If we plot graph between t and s, whatever be the type of the graph, it might be straight line, it might be a curve as I have shown here. If you draw one tangent over a point and take the slope of this graph, this is tan theta. Tan theta will be equal to slope of this graph. Tan theta. You might say that velocity is equal to slope of TS graph. And slope might be considered at any point. See, here, here, anywhere. If the graph is this way, same graph, but the type has changed. Here you would say that slope is decreasing. Here the slope is regularly decreasing. In this case, the slope is regularly increasing. You have to remember the slope of TS graph is equal to velocity. Instantaneous velocity will always give you the value of magnitude and direction both at a particular instant, whereas average velocity always gives you the value for a given time interval.